Today I'm going to teach you how to solve system equations. I will show you the three-equation system, a system of equations using elimination, and then a system of equations using substitution, and finally graphically. Before we will start, we will go over definitions that you should know. System of equations. When two or more equations are solved at the same time. Solve graphically. Graph the systems on a coordinate plane. Solve algebraically. Use substitution or elimination to solve a system. Consistent. A solution with an equation with a solution. Inconsistent. An equation that does not have a solution. Here are some little notes to keep in mind. A line is known to be the solution set. Parallel lines have no solution set, meaning that that they are an inconsistent solution. Lines that intersect have one solution. That is the point that they intersect at, and they are a consistent solution. If the lines overlap, meaning that they are the same, then they have infinitely many solutions and are known to be a consistent solution. And now I will show you how to solve a three-equation system step by step. Solving a system using three equations. First, you'll be given three equations. Choose any two equations from the three equations. Then choose the variable that you want to eliminate. Eliminate that variable from the two equations that you choose. After you eliminate that variable from those two equations, choose a different pair of equations and eliminate that same variable from those equations you just chose. Now take your two new equations that you got from the original equations and choose a variable that you want to eliminate from these two equations. After solving these two equations, you'll be given a variable that is equal to a number. Take that variable and plug it into one of the new equations. After you solved that equation, you will now have two variables that are equal to numbers. Take the two variables that are equal to the numbers and plug them into one of the original equations. After you solved that equation, you will now have answers to all of the variables. So put the numbers in parentheses in alphabetical order, x, y, z. So if x was equal to 2, you would put that number first. If y was equal to 3, you would put that number next. And then finally, z, if it was equal to 4, you would put that number final with a parentheses after it. Meaning you would end up with 2, 3, 4 with parentheses on each side. Now we will jump in and solve the equation that I have given to you. You are given three equations. The first is 5x minus 4y minus 5z equals 12. The next is 4x plus 4y plus z equals 24. And the final one is 2x minus 4y plus z equals 0. The two equations that I chose to solve for a variable first are the first two equations, 5x minus 4y minus 5z equals 12, and 4x plus 4y plus z equals 12. As you can see, the 4y's in the first equation and the second equation cancel out because one is a negative and one is a positive, making it equal to 0. Then you add up 5x plus 4x equals 9x, and then 12 plus 24 is equal to 36, and then negative 5z plus z equals 4z. The next equations that I chose to eliminate the other y's were the equations 4x plus 4y plus z equals 24, which I used in the previous two equations, and then 2x minus 4y plus z equals 0. I add the 4x and the 2x together, getting 6x. 4y minus 4y equals 0, canceling those two out, and z plus z equals 2z. And then 24 plus 0 is 24, leaving you with 6x plus 2z equals 24. Now you will take those two equations and make them a system, and then solve to get a variable. On top we have 9x minus 4z equals 36, and below is 6x plus 2z equals 24. And because there are no common numbers in this equation, you need to multiply one of the equations by a number so that you will have a common number in each equation, one being positive and one being negative. As you can see, we have a negative 4 on top, negative 4z on top, and a 2z on bottom. So you can multiply the bottom equation by a positive 2, leaving you with the equation 12x plus 4y equals 48. So now write out the equations again, and you have 9x minus 4y equals 36 on the top, and then below is the new equation 12x plus 4y equals 48, leaving you with 21x equals 84. Now you can divide that by each side by 21, leaving you with x equals 4. Now, as you remember, you will plug x into one of the new equations that you got from the original equation, and I chose to plug x into the equation 6x plus 2z equals 24. I multiply this 6 times the 4, getting me 24, and then I have 24 plus 2z equals 24. I subtract 24 from both sides, leaving me with 2z equals 0. I divide both sides by 2, leaving me with z equals 0. Now I take one of the original equations and I chose the equation 5x minus 4y minus 5z equals 12, and I plug in x and z into that equation so I can get the answer to the variable y. So I multiply 5 by 4 minus 4y, and then I multiply negative 5 by 0 with the equation equaling to 12, ending me up with 20 minus 4y minus 0 equals 12. Simplifying it to negative 4y equals negative 8, now you divide both sides by negative 4, leaving with y equals positive 2. Now the final step is to write the answer. So you will write 4, 2, 0, all in parentheses. Now we will solve systems using elimination. The first thing you need to do when solving a system using elimination is to check and see if one of the variables has the same coefficient in front of it, but one of them is positive and one of them is negative. For example, one equation would have to have a negative 2x and the other would have a 2x, so that they could be eliminated. If the coefficient cannot be eliminated by itself without having to multiply it with a number, you will have to multiply either one or both of the equations by a number so that you can eliminate one of the variables in this equation. After you eliminate one of the variables, you will have a variable equal to a number. Plug that into one of the equations so that you can get the variable that you have not gotten yet. Now you will have two variables that are equal to a number. Put those two variables in parentheses, x first and then y, and that is your answer. Now we will go into solving systems using elimination. The two equations for the system are a negative 8x minus 10y equals 24 and 6x plus 5y equals 2. As I previously said, to eliminate a variable, you need to have the same number in front of the variable, one having a negative and one being a positive, so that they can cancel each other out. So the way that I have chosen to eliminate one of the variables is to multiply the bottom equation by 2 so that I can get 12x plus 10y equals 4. So in the next step, we'll write out negative 8x minus 10y equals 24, and then below that 12x plus 10y equals 4, giving us 4x equals 28. Divide both sides by 4, getting x equals 7. Now take x equals 7, take the 7, plug it into negative 8x minus 10y equals 24. So you will get negative 56 minus 10y equals 24, then negative 10y equals 80, giving you y equals negative 8. So put in parentheses 7 comma negative 8, and that is your answer. Now I will go over the steps for solving systems using substitution. When solving a system using substitution, the main goal is to find the equation that has the variable without the coefficient in front of it, meaning that it will just be a plain x or a plain y, with no number in front. This is helpful so that you can have the variable without the number in front of it on one side of the equal sign and all of the rest on the other side. Once you have the x or the y on one side and the rest of the problem on the other side, you can plug that into the other equation and solve for the system. After you solve for one variable, you can take the number that you received from the equation and plug it into the other equation to get the other variable. After you have both x and y, put it in parentheses, and you are complete. In this system using substitution, the two equations are 7x plus 2y equals negative 19 and negative x plus 2y equal 21. What I decided to do first was take negative x plus 2y equals 21 and put the x on one side of the equal sign and all of the rest of the equation on the other side. Now I will take the 2y minus 21 equals x and plug it in to the x in the 7x plus 2y equals negative 19 equation. And I solve for y. So I have 7 multiplied by 2y minus 21 plus 2y equals negative 19, giving me 14y minus 147 plus 2y equals negative 19, then getting 16y equals 128, divide both sides by 16, leaving me with y equals 8. Now I will take the 8 and plug it in to negative x plus 2y equals 21 equation. Now I have negative x plus 2 times 8 equals 21. Then having negative x plus 16 equals 21, giving me negative x equals 5. Divide both sides by negative 1, getting x equals negative 5. Now I will put that in parentheses and I have an answer of negative 5 comma 8. And finally I will show you how to graph a system. First you'll write out the problem in the form it is given to you. And then what I like to do is to write it out in slope-intercept form, which is y equals mx plus b. Choose the first equation you would like to graph. Look for the y-intercept in the formula, which will be the b. Take that number and plot it on the y-axis, since it is your y-intercept. Then look for the slope and use it to plot your next couple of points so you can make a line. Now it is time to graph your other equation. Repeat the steps from before, so find your y-intercept, then use your slope, which is rise over run, to connect your points, and then connect your points with the line. You are not done quite yet, so find the point of intersection. And a little side note, not all systems have a solution, but this one does. As I said before, The lines that intersect have one solution, which is a point. The parallel lines have no solution, since they have no points in common, and then the lines that overlap onto one another have an infinitely many solutions. Now it is time to graph the system. We are given two equations for the system, 4x plus y equals 2, and x minus y equals 3. As I said before, I like to put it into slope-intercept form, so I get y equals negative 4x minus 2, and y equals x minus 3. I will first graph the equation y equals negative 4x plus 2. So I will put a point on the y-intercept axis on 2, and then I will go down 4 into the right 1 and plot a point. And then do that again, and then connect the points with a line. Then I will do the equation y equals x minus 3. So I will plot a point on the negative 3 on the y-axis, and I will go up 1 into the right 1, and then do that again a couple more times so that I will have enough points to make a good line. Now it is time to find the point of intersection. And a tip is, if it is hard to find the exact point, plug it into your calculator, graph it, and ask for the intersection, and it will give it to you. Finally, write if the equation had a solution or if it didn't, and if it did, write what type of solution it did. And for this one, it had one solution, and it was a consistent system. And that is all that we have for graphing systems. Thank you for watching.